I'll give you the homework number 3 by Thursday. Let me see where we are by Thursday. It's going to be about this DC to DC converter. And the due date would be this is a big 7. You're going to have, because I'm thinking to give you one more homework. I think I can go over the resonant converter also. That will be the last part of the course. Hopefully I can finish this DC to DC converter by next Tuesday. All I want to go over it by next Tuesday. Next Tuesday we can stay a little bit longer, like 30 minutes longer, because it's still, I owe you another 40 minutes, but 30 minutes to play. We'll stay 30 minutes, and I'm hoping by next Tuesday we can finish the DC to DC converter. And next week is week 8. So we can put the homework to you first Tuesday of week 9. And after that we're going to go over the resonant converter. Now, today we're going to work on the linearized model of the DC to DC converter. Let's see what it is before we start. If you look at the system with the block diagram we had, we say here we have Vref, and we had a V actual, and we said we're going to have either compensator, controller, whatever we call it. We're going to have that one. And after that, I said we are going to have a PWM generator. This is the block diagram we wrote a few weeks ago, I think maybe 2 weeks ago. PWM generator. And after that, we said we have a plan. And this is a view. For example, we want to control the view. Right? Still, we're working with the plan. Still, we're in this part, working in this part. We went through the state space equation for the block and boost converter. Now, to put it on this plan, all this DC to DC converter, think about it. You guys, you are in the lab, you put it, for example, 5-volt output, right? You say, we're going to have 5-volt output. I don't know, in the next step of the experiment, you say, for example, do the experiment with 7-volt, right? Now you are going to change the set point to 7-volt, right? You are in the 5, now you are changing to 7-volt. And now you want to keep the voltage around the 7-volt. If you look at it, this VO is supposed to be, it was 5 and now it's 7-volt, right? It was like this, for example. There is a ripple here, right? We need to design the control system to keep this one here, right? To do this one, there is a method, they call it a small signal model or linearization method. What we do, we linearize this model of this power plant is a block, boost, whatever converter it is. We linearize that model, and we'll find a transfer function for this. If you look at the inverter, remember what we did? We said ID over ID ref. I'm going to put the ID ref over ID ref is a transfer function, right? And you can use it for your control purposes, right? Here we want to do the same. We want to use the transfer function of this plan. So you know what is the transfer function here. And after that, this one is a very simple block. I'll tell you what it is. The PWM generator. This one is either PI controller, is the PID controller, is the second order compensator, different controllers. We go talk about the one or two specific one, about this one, and we design this loop, and we say how to design this loop. Still, I need to complete this box here to see what is the model for this one. Now, if you look at here, every parameter here, we have the IL, VC, VO, Vin, and V and V, right? These are the parameters we have. Duty cycle, input voltage, output voltage, VC, usually output voltage, VC and IL, right? For example, if this is in this case, for example, we had in the buck or boost converter we did VO was a VC, right? So I cannot put this one as an independent parameter. We have a VC, right? So this is a VC. I can say this VC is equal to a VC plus VC tilde. So this VC is a DC operation point, is this value, right? and this VC tilde is the ripple on this one, or going around this one, right? So I wanna get the equation based on this one, because usually we want to minimize the ripple. We want to make sure the control is good. So this is a DC operation point. We are going to go from here to this point. We are going to go from 1 volt to 5 volt. But now I'm going to have I need to have control to control the ripple here, to keep the system at this point, right? So this VC, we're going to see how we're going to get the equation. For example, IL, again, is going to be a IL plus IL tilde, right? It's going to have a DC value, right? Plus a ripple. We call it IL tilde. D, even D, if you look at it, D is going to be in the control loop, closed loop control, not the open loop. In the open loop, you set a D 0.8, I don't know, 0.7, 0.5, right? So it's a fixed number. But in the real system, in the control system, if you go look at your D, D is going to go up and down, up and down. Did you simulate the flyback already? Did you look at the D over there? So look at the D. It's not going to be a perfect, for example, 0.8 or perfect 0.9. It's going to be, for example, 0.9 with something on it, right? So again, here, if you see, that's the DC value of the D and the D tilde, right? So let's put it here, a small signal model. I want to find a small signal model of this converter. So, in general, for any converter we have, how the phase 3 is going. Is it good? Phase 3 project. Its due date is the first Tuesday of week 9. You know, be careful. You have almost 2 weeks. Almost 2 weeks. Not almost, exactly 2 weeks to finish the first phase 3. Is it going well? Have you worked on it? There's lots of work. Believe me, it's lots of work. You know, if you're not working on it, be careful. You know.
Finishing up the sim project.
Huh?
Or just finishing up that sim project. The simulation project due Thursday.
The flyback converter.
Flyback
Yeah.
Flyback is not project, it's a homework, right?
Oh.
That's very different. Tell you put this one, put this one, put this one, put this one, this is a homework. This one, the other one is not homework, it's a project. That's different, you know. Yeah, the flyback don't count it as a project. It's kind of, you know, simple things. You do it quick, you know, right? Let me see. This is the boost converter. Just I want to make sure this is the So, as we said, we have 4 parameters usually. We have I'll put it this way. VCT is going to be VC plus VC tilde, all the parameter, ILT. So I show this one with a VC, this one with the IL. If you later you see, it's going to be IL plus IL tilde, VC IL, DT, which I show it with D. This is a duty cycle. It's going to be D plus D tilde, and you have one more V in. V in, which we show it. V in T. This is going to be in plus, usually V in tilde is 0. Usually the input voltage, usually I'm saying, sometimes it's not, you know, but usually V in is fixed. I'll give you one example. The V in is not fixed. Later on I'll talk about, you know, the one you're dealing with. You know, I told Arnold to work on the third one, the simulation homework. I want you to do the MPPT with the buck converter. They are going to do it next week or this week. I'm not sure when we're doing the buck converter. But I want to do the MPPT with the buck converter. Doesn't matter. It's an inverter or converter. The algorithm is the same thing. This is the same thing, same algorithm, you know. But you will work on it. You see, V in should be changed. So we have all these four parameters. If any of them they are zero, if any of them is fixed, somehow you have a perfect battery you put here, right? How much is V in tilde? Zero. So V is constant, right? So basically V in tilde. Now we'll consider one more assumption here. Whenever I have a VC tilde, for example, times IL tilde, or VC tilde times, I don't know, D tilde, or any combination of these four, right, is almost zero, right? Because there are the small changes. This one, they're supposed to be a small change. One small number times another small number is going to be a very small number. We assume that one is almost zero. So we use this thing, you know what I'm saying? Any of these tildes times another tilde, we assume is zero, right? Now keep this one in mind, what I said here. Let's go back to the buck converter. If I'm right, it was like this. Switch right here. Right, this one was the buck converter. Now we want to find the the parameter we are looking to control is VO, right? Or VC, right? Because VO and VC they are the same, right? Let's say the parameters I have under my control, I can change them. Those ones I can change them to control the VO. What are those parameters? One is the duty cycle of this switch, right? I can change this duty cycle to control this VO, and what else? Right? V in, right? I'll put a V in for now as a variable, but usually V in is constant, right? Let's start with a variable to get the equation together. But after that, I'll say, okay, V in tilde is zero. I'll get rid of that one. You know, I want to find my goal is to find a goal. My goal is here. VO tilde S over VS. This is a transfer function I'm looking for. This is a transfer function I'm looking for. If I have buck converter, I'll put the transfer function here instead of this buck converter. Hey, this is what we have, right? Now, let's say how we can calculate this one. And you know, S is the Laplace parameter, right? Everybody knows that, right? And S is the Laplace parameter, you know, because I remember last year I was teaching this one. I was almost done with all this chapter. Somebody asked me what's S. Somebody asked me what S. Let's say right now. S is the Laplace, you know, variable. You say, you know that, right? Laplace transform. All of you are familiar with that, right? Yeah. Okay. Good. Now, let me go over the equation again. Let us see. The goal is to find the. For example, I find something here for this part. For example, I find this is the LS plus R, I don't know, over CLS2 plus, I don't know, RS plus whatever. My goal is to find something like this for this part. You know what I'm saying? So after that, I don't care what the buck converter. This is a mathematical model I can use for my stability analysis, for control design, for whatever I want, right? So this part is easy. Still, we are not in the control part. It's just kind of playing with this, I don't know, equation, this kind of thing, to find this transfer function. And you can do this analysis for any power converter you want. Flyback, forward converter, half bridge, full bridge, whatever you want. Now we do it for the simplest one. We do it here for buck or boost. and we'll leave the rest for you guys. You know, if you want to design something, you can do it yourself. Now, again, there are two modes, right? Mode 1. Let's start from what we have. Switch closed, right? Switch is on. Switch is on, the circuit is like this. Let's find, we did this one already, you know, but let's find the equation one more time. Here, I'm going to write it quick. We said L dIL over dt is going to be V in minus Vc. Am I right? What is the V in minus Vc, right? And the next question, next equation was we need to write something for Vc. This is a R, right? And this is a IL, this is a IC. We said IC is equal to C dV over dt, right? C dV over dt. C dVc over dt is equal to IC. So IC is equal to IL minus IR. And IR is Vc over R, right? This is when the switch is on. Now, when the switch is off, we have this circuit. That's all. This one is open. So equation is going to be L di over dt is minus Vc, right? L dIL over dt is minus Vc. The same equation because V in is not anymore in the circuit, right? And the second one is up, so the same thing. C now, this is what we had before. I'm going to go replace all these parameters with this. There is still, right now there is no D, right? Keep in mind there is no D. I'm going to go replace all this equation with this one I have here. So this one becomes L d over dt IL plus IL tilde, right, is equal to V in plus V in tilde minus Vc minus Vc tilde, right? That's the equation I'm writing. The second one I'm going to write it also is going to C d over dt Vc plus Vc tilde is equal to IL plus IL tilde minus Vc plus Vc tilde over R, right? That's the same equation, just I'm replacing all of them with a DC value plus a tilde value, right? Let's simplify this equation. How much is this one? D over dt IL. How much is it? Zero. Why? DC. Because it's a DC value, right? So basically this side is going to be L d IL tilde over dt, right? This is one. Over there is going to be V in plus V in tilde minus Vc plus Vc. Right. Now, let's come here. Again, how much is the d over dt Vc? Zero, because it's a DC value, right? So basically, C is equal to
Professor,
Yes.
back to the equation you have on top, first one.
Uh-huh.
The plus in there.
This, oh, this one is not. This one should be plus. Yeah. This one should be plus. So IL tilde minus VC over R plus VC tilde over R. Minus. So we have this one. Now we'll go for the second circuit. Again, listen, I'm not writing it right away, okay? So this IL, let's write it first time. This is going to be T. Right, and this one is going to be C. Right, this is what we have. I don't want to write all the equation, you know. I'm gonna do this. Right. I can divide by C. I can divide them by L, right? The same thing here. You guys, you can write it one more time, you know, if you want. Right. The same equation, just I want to find the DIL over dt and dVc over dt. That's my intention, to find the value, right? Now, this equation is valid for dt time. This equation is valid for 1 minus dt time, right? So if I want to find the general equation, I should average out this equation, right? Let's start with the DIL over dt. So d I tilde over dt, actually I should put a kind of bar over this one. I'm not going to use two notation, you know, just I'll put this one. So it's going to be d times this, right? Plus d minus 1 minus c times this, right? It's going to be d times 1 over L v in plus v in tilde minus dc minus dc tilde, right? Now, oh, plus what? 1 minus d times what? This, right? It's going to be 1 over L minus dc minus dc tilde, right? I'm gonna go finish this one first, and I'll come back to the dc after that. Okay. So what is this d? D plus d tilde, right? D is a d. gonna replace d with that value and time it, and let's write all the terms. Basically, di tilde over dt is gonna, I'm gonna write all the terms. So d over is gonna be d capital over L v in plus d over L v in tilde minus d over L vc minus d over L vc tilde, right? I just timed d by this, all the terms over there, right? Can you see it, guys, here?
Yes.
Yeah. So just I'm timing one by term here, just I'm writing it here. Next term is going to be d tilde over L v in, right? This one times this, right? Plus d tilde over L v in tilde minus d tilde over L times what? Vc minus d tilde over L Vc tilde, right? I timed also this one by all the terms. Now we need to do the same thing for this side. So it's gonna, we start with 1. It's gonna be 1 times this is gonna be minus 1 over L Vc minus minus Vc tilde over L, so I timed 1 to this equation, right? Now I should do minus D, minus capital D, right? So it's going to be plus D over L, check it to make sure I'm correct, Vc, right? See, there's a minus times this minus is going to be positive, right? D times D over L times Vc, D over L times Vc tilde, right? Plus D over L Vc tilde. This is just a simple calculation, it's not very complicated. It can be big, but it's not kind of complicated things, just to let you know. So we time this one also to both terms. Now let's go for the d tilde plus d tilde over L Vc plus d tilde over L Vc tilde. Am I correct? Now let's see what is going to cancel out. Let's look at here. It's going to get me 2. How much is this one?
0.
Why?
Because
You have a d tilde times v in tilde, right? So this one gone. 0, right? Let's see, can we find here? There is another one here, right? This one is again 0, right? Do we have any other term? Nothing here.
Very last.
We have here the last term also. So 3 of them they are gone, right? Now let's see, do they any of them cancel each other? Let me look at this one. Let's look at this one and this one, right? Just put them like this, right? These two they are going to cancel each other. Let's see if we have anything else. They cancel each other.
DC form. Yeah, D over L, DC tilde.
Which one?
D over L. D over L.
These two, right?
Yeah.
Let's put it this way. Anything else?
And then stay here. D over L. Yeah. DC.
We're talking about these two, right?
Yes.
So let's put it in a circle. So what else do we have? So these two they are gone. We have 2 terms here, and one is in DC. So let's write it down. Let's write it down now. I'm gonna write it here. Or I'm gonna put it here. You don't need this one anymore. dIL tilde over dt is going to be, I'm going to write it in the form of a state space equation again. First, I'm going to go with the term, do I have any IL here? See, I have this term, this term, this term, this term, this, there's no IL, right? So I put a 0 IL tilde. 0 plus. Do we have any VC tilde?
Yes.
Which one? You have one here, right? That's it, right? Okay, let's write it down. Right? Yeah. Now, so I wrote this term. Now we need to write the rest of it. Let's start with this one. And then I will also plus Q over L. Okay. We have that one first. I wrote this one. I wrote that one. This one is this one and that. Right? Did I miss any terms or not?
Okay. Okay, okay.
So we have minus 1 over L VC tilde, that's correct. B in over L B tilde, that's correct. Plus B over L B in is correct. This one should not be here. Somewhere happened. This one should not be here. Let's see. Where did we miss it? Because here, look at here. I have a D over LVC and I have a D over L minus D over LVC. So
But that comes from the 1.
the 1, right? One over LVC. This one I know. This one, if we assume V in tilde is almost 0, that one is gone. Let me just check here. Oh, I know. Oh, yes, I got it. 2 is correct. Okay. There is one more thing. Look at this term. I'm going to take a factor, 1L, right? It's going to be minus VC. I'm writing this two terms, right? Plus DV. How much is this term?
0.
How much is it?
0.
Why?
That's the converter.
VC is VO, that's a bulk converter, right? You can write it here, write that equation here. This one is going to be 0. Right? This is a steady state condition. So basically, these two terms are going to cancel each other, right? So my equation here is going to be like this. My equation is going to be like this. Just I want to make sure everything is correct. Yeah, this is correct. Now we are going to go for the is this one? Yeah. D over D I L tilde is minus 1 over C plus D in over D tilde, right? Yeah, that's it. This is the first equation. Let's go for the second equation now. We need to do the same thing for these two. We need to go for the same thing for this. So let's do it quickly. dc tilde over dt is going to be d times this, right? D times this is going to be d over c times il plus il tilde minus dc over r. So it's going to end really, the result is going to be very simple, but you have to go through all these calculations to get there. So this is the first one, right? D of this one, 1 minus d of this one, right? Plus 1 minus d of il right? Now, let's replace d with the d plus d tilde, right? And again, the same thing here. D plus d tilde. And let's time all the terms and again simplify. You know, it's going to be, again, long, many terms, but they're going to cancel each other, all of them. So, dvc tilde over dt, let's time it. It's going to d over cil plus d over c il tilde minus d dc over r minus d dc tilde over r, right? Am I right?
RC.
Oh yeah, there is c. Right, there is c. So now let's go for the second term. It's going to be plus il plus il tilde minus dc over r minus dc tilde over r. So I time all divided by c. All divided by c. Now we go for capital D over c times that, right? It's going to be minus d il over c minus d il tilde over c minus, that is, yes, minus, plus so 1, 2, let me see. It starts from here, il 1 over c 1, 2, 3, 4. Now we take here d over cil, d over c il tilde plus d dc over rc plus d dc tilde over rc. So we did this one. Now we go for the d tilde. It's going to be minus d tilde il over c minus d tilde over ci tilde. We did these two. Let me put them there. Plus d tilde vc over rc minus d tilde vc tilde over rc. Right? Let's see again which terms there are zero. Let's go through those ones, see which terms there are zero. So we start with the easy one. Wherever we have d tilde times that something, you know, we're going to get rid of those terms. How many of those one we have? Did I put this? Oh, you know what? I missed this part. I didn't time this d tilde to this one. I'm like, say here, just I missed it here. No, I need to add more terms here. So d tilde, because I look at it, there is none of those one. You don't time each other. You know? D tilde over c times il, right? I missed this one. D tilde il over c plus d tilde il tilde over c minus d tilde vc over r minus d tilde vc tilde over rc, right? So I missed this term here when I timed it. I missed this term, right? Yep. this one.
No, not that one. No.
This one should be plus, right?
The one that you just added.
Here,
Yeah, the second, the last check.
this one. I see, yes. It is already there. That's right. Now let's see which one is going to be 0. So this one, 0, right? We have a d tilde I tilde. This one, 0, right? What else? Distance 0. So this one 0, right? 4 of them, they're gone. Let's look at the rest. Do we have anything they cancel each other? DC over IL. Do we have anything like this over there or not? Yes. So I'm going to go like this. This one, DC over IL, is going to cancel, sorry, DIL over C. These two are gone. What is the next? Let's go with these two, right? So let's go like this. Right? These two. Let's go like minus DVC tilde and RC. Let's go like this. Right? So what else? Which one and which one? This one and this one?
Yes.
Right? So this one and this one. And this one and this one, right? So do we have anything else? No, this one they are all gone, this one they are all gone. So we have only this part, right? Let's write it down. Let's write down this part. I'm gonna write it here. dVc tilde over dc. dVc tilde over dt is gonna be, I'm gonna go with the order I want. 1 IL tilde, right? 1 over C. 1 over C IL tilde. Minus 1 over RC VC tilde, right? Minus 1 over RC VC tilde. So these two they are gone. Now plus IL.
You want
Over-
zero delta, P delta first, right?
Right? These two, right?
But you want to write them in the order, right?
Yeah, let's put it this way. Of IC times IL minus VC over R. Am I right?
Yes.
That's
That's
zero.
zero. That's zero, right?
Why?
Because instead you say IC is zero.
I'm going to say this one is 0. Let's look at what? These are DC values, right? If we have a L here, the circuit is like this. We have a C and we have a R, right? We said IL is equal to IC plus IR, right? Right. So IL average is equal to this thing, right? Is equal to IC average plus. How much is the IC average?
Zero.
How much is the IL average? Is IL, right? How much is the IR average?
DC over O.
DC over R, right? So how much is this term?
Zero.
This term again is 0. See, the equation become really simple. You know, lots of calculation, but at the end it's becoming really simple. Now, let me put the state equation here. So it started really bad, but you can see it got better and better and better. Now think about it. If this one has a R here, right? Think about the calculation you have to go through. You know, I'll give you one in the homework. You know, you have time at home to spend on it, but
We have a project, no?
yeah, but life is difficult. Yeah.
Make it more difficult, right?
Yes. Is 0 plus D over L. DBC just let me double check to make sure. Yes, that's right. 1 over C I tilde minus 1 over RC. I'm not going to put it on the state space form. We can put it that way if you want. You can let's put it there. No? It's going to be d over dt just compare this one with what we have before, even doing the small signal. You can see this part is not changing. This part is staying the same. Plus, we have two parameters here. D tilde I'm going to write it this way. Usually they put this one also in a matrix form. If you are going to look at this one, they put it in a 2 by 2 matrix. You can write in a 2 by 2 matrix, you know. But I didn't want to put it that way, you know, just I kept it here. What was the goal? The first thing I put it here. I said I want to find out VO tilde over D tilde S, right? That was the goal. This is what I want to find. This is a transfer function I want to find, right? I can use these two equations. Let's assume when you have two variables, see, two inputs, either D can change or V in can change, right? If you want to find a transfer function, you make one of them 0, right? And you find the other one. You know, for example, what's the transfer function for that one? And superposition, right? You call it superposition term, right? So you can say this one's 0, right? This one's 0. Let me see what's the transfer function. And I'll put it here. I can write V over tilde is, I don't know, they call it G or F. I'm not sure what they call the transfer function. Let's call it G, T I call it. No, not T. T is the compensator. TP. TP1S times D tilde S plus TP2S. You know what I'm saying? You have two inputs here. V in tilde, you can change the V in, right? The tilde, you can change the D, right? Usually the one is important for us is this one. Because we don't change, if we change the input, if that one also is important, you know, keep in mind. If we change the V in, this one also is important. But if the input is fixed, is a DC source, right? There is no tilde, right? How much is the V in tilde is 0. If V in tilde 0 is 0, so this one is gone, right? So I'm saying here, assume V in tilde is equal to 0, right? So if V in tilde is equal to 0, this one is gone, or this one is gone. right? We don't have that one. Now I want to find the TP one. I want to find the TP one. TP stands for transfer function of the plan. TP. I call it TP. No, this one, these are the same. No, because I'm not going to find both of them. This is just the TP, right? Let's find it. How should I find it? Let's write the equation here. How much is the Laplace transform of DIL tilde over PT? Is IL tilde S, IL tilde S, right? I'm using this equation. Number 1, number 2, right? Number 1 is said SIL S tilde is equal to, this one is 0, is going to be minus 1 is equal to minus 1 over L VC tilde S, right? Plus V in over VL D tilde S. There is no V in tilde anymore, right? So 1 and 2. 2 result in, we'll put it here. How much is this one? S VC tilde S, right, is equal to 1 over C ILS tilde minus 1 over C VC tilde S, right? And VC is a VO, right? VC is a VO. Basically, I want to find the VC over D, right? That's my intention. I want to find the VC over D. What should I do here? I should find the IL, for example, from this equation, right? Substitute in the top equation, right? How much is the IL tilde, ILS tilde? So basically, it's going to be CS plus 1 over R, right? This one is going to go to that side, times by C. VC tilde S, right? Is it correct? And from this equation, I find the IL. Now I replace IL to this equation, right? I use this equation here, right? So I'm going to replace IL with whatever I have over there. SILS, right? So it's going to be S times CS plus 1 over R VCS tilde is equal to minus 1 over L VCS tilde plus V in over L V tilde, right? Now, just I bring this term to this side, right? I factor VCS tilde, right? So let's write it down. It's going to be CS square plus S over R. This is these two terms, right? Bring this one to this side. It's going to be plus 1L, 1 over L, right? VC tilde S is equal to this term, right? V in over L. How much is the VC over? How much is the VC tilde over D tilde? So we need to time this one by L divided by V in, right? So it's going to be 1 over V in times LC S square plus L over R S. Am I right? No. It's going to be V in, if I'm correct, it's going to be V in. Over that. Right? It's going to be LCSS square plus L over RS plus 1. So this is the transfer function of the buck converter. If we are going to see the if you are gonna see the effect of d tilde, right? So think about it. When I have a controller, this is my plan. Plan means this. I don't care what was the circuit, which switch was on, which switch was off. I don't care. Forget those parts. I replace my plan with this one. Here, right? Just to make sure the V in. Oh no. Looks like we have one mistake. Let's see. No, that should be correct. Because I want to make sure I didn't make any mistake in my calculation. I believe I did it, but let's make sure. Does anybody have the book with himself, the Daniel Hart book? You have the book? It's in chapter 8, I believe, or 9.
What's the book?
And put the equation there, no, just went through that and put the equation, final equation there. We have one S, we don't have that one. It's a VO over D is equal to VS over S, this is correct, up to here. But, no, let me see. This one. Oh, very good, okay. So because the one he has here, he had the RC, the resistor for the capacitance, because this is correct. This is correct, we didn't make a mistake. Now, from now on, this box is this for me. I don't care anymore what was the calculation. When I have buck converter. So, like the inverter project you are working, you calculate your MA, right? MA is going to be something like this, right? What you do with this MA? You cross this one with a triangular waveform, right? You cross this one with this, right? You cross this one with this, and what is the output of this one? You get something like this. You get a pulse here, right? This is what you are going to get, right? This is a PWM generator. It's going to get a duty cycle converted to a pulse. These pulses, they have the same average as of this D tilde, right? So basically, your system is going to be like this. You are going to have D coming, it's going to go to this PWM generator, right? This D you have here, right? It's going to come to this PWM generator, and this one is going to go to the plant, right? We need to find the transfer function of this one. So D is coming to this PWM generator, and we have the compensator here. So we calculated this one. We calculated this model in this. If your project is somehow, the D is fixed, you don't want to change your duty cycle. You are on 0.8, for example, 0.7, whatever, right? Now you want to control, you have a variable load. You want to control the output with a V in, right? You want to control the output with a V in. So basically, you go with a transfer function of this part, right? Give me one example. If I'm going to give this one in a book simulation homework. You work with R with that. Think about this one, guys. You have a buck converter. Buck converter. And this is your out. Right? Here, what we are going to do here, maybe not, this is a very non-linear, but I need to think about it. If it's simple, I give it to you guys to do. In the solar panel, so this is V in, this is V out, right? This is V out, right? So when you do the MPPT, right? When you do the MPPT, what you are controlling? What parameter you are changing? You want to control this voltage, right? You don't want to control this voltage anymore, right? You want to control this voltage. With what? With what? With the cycle. So basically, you guys need to find the transfer function of, right? Because what you do in this system, you want to set the voltage here, right? You want to always keep the voltage here, right? It's like a power supply. You want to have a 7-volt output, 10-volt output. In this case, you want to have a converter. It has this much fixed input voltage, right? You want to control the input. So you need to think about it, what you want to control in your system. In a power supply, what do we want to control? Output voltage, right? You want to have 5 volt, 10 volt, 20 volt, whatever you want. In the solar converter, solar system, I want to control this voltage. Why? Why I want to control this voltage? Because I want to be able to change it to get to this point, right? So here in control, I want to control my output. I mean output of control system is V in. I want to control this one. With what? Did you decide? I'll need to think about this one. It may get very non-linear. I need to work on it myself at home to see if it's not non-linear. I'll do the homework for you guys simulation. This would be another example of going through the control parameters here. Now, so we figured out this one. This one is going to be here, right? Before moving ahead, I'm going to go through the boost converter very quick. I'm not going to go through one by one. I want to finish the boost converter transfer function. So this is a buck converter transfer function, right? Let's get to the boost converter transfer function. Because Tuesday or Thursday, I want to talk about the PWM generator is very quick, and after that, I want to get to the compensator, the other part. So now boost converter. So boost converter, we have a V in. So what you should do, switch open, switch close, switch open, two set of equations, right? And you go replace the V in with the V in plus V tilde, VO with a V, not VO, VC with a VC plus VC tilde, D is equal to D plus D tilde, all those parameters, IL the same thing. So I'm not going to write all those things here, You guys are going to do all those equations. So Is it okay if I'll put the final equation here?
Yes.
Yeah, let me just put the steps. You know what you're gonna go. One, you're gonna get the state space. Equation. You can do the tilde here, or you can do, let's put it 1, average. We found this one already, right? For the boost converter, I should have started from here. We found this one for the boost converter, right? Now, step 2, what you are going to do? D is going to be D tilde plus D, right? VC is going to VC is going to be VC plus VC tilde. IL is going to be IL plus IL tilde. And what else we have? VCIL. V in. And V in should be V in plus V in, right? We already have this equation. Go to the notes you have, right? Just go to that equation directly. You don't have to do it the way I did it here. The final equation I found for you, right? For the box and for the boost. I found for both of them. Go to induce the equation and replace ILVCD and ILVC and D and V with these values, right? Do the calculation, timing, all those kind of things. You're gonna get to this equation. This is what you're gonna have. There is a step here. You do this part. So we're gonna get to a step. This is a step 3. You do that one. A step 4. Then you get to the step 4, you're going to get this equation. DIL tilde over DT is equal to, let's write, because D tilde VC plus V in tilde minus 1 minus D VC over F. And dVC tilde over dt is equal to 1 minus d IL tilde minus d tilde IL over C minus VC tilde over R. So this one is not in your book. No, this one you cannot find in your book. Now you will find this equation. This is the important part. You got to this equation. You have a DIL tilde over dt, dVC tilde over dt. Now let's get to the transfer function. Again, VO is what? VC. Based on what transfer function you want, you can calculate it. For example, you want a VO over D, or you want a VO over V in. You know what I'm saying? So you can calculate that one. The best book for this part, they call it a small signal analysis, I have seen is from University of Colorado. That's by Erickson. The book is in one of your references. That's the best book. If you want to work on the power supply, DC to DC converter is like 500 pages book. You know what I'm saying? It's all about this kind of thing. It went through the detail of everything. Very, very deep. We cannot do that one here. But it is the best book I have seen for the DC to DC converter. Analysis of the dynamic analysis of DC to DC converters, and design. So it's a pretty heavy book, I mean, even technical, some books they have only lots of pages, but it's easy to read them. But this one is lots of calculation things behind it, Now we have this equation. We can go find our transfer function. For example, here I'm going to find all combinations. For example, VC tilde S. This is the one most of the time we are interested in, if we are going to control the output voltage. Because VC is a VO, right? VC is a VO. So this one is going to be so if we have a boost converter, for example, I give you a homework. We have a boost converter, we want to control the output voltage by controlling the duty cycle. So we go to this model. This is the model for that boost converter. Now, for example, can somebody give me an example for this case? Can somebody give me an example for this case? And this is a detailed level. Have you looked at the power supply? You can put them in the voltage mode or current mode, right? So look at here, this is your power supply for this R. This R is where you want to connect this one, right? Where this is those leads you go connect it to whatever you want, right? If I want to be not this one, let's go back to the buck converter, for example. Buck converter, the circuit was like buck converter. Was it like this? I think buck converter was like this, right? Right, and this leads goes to 12 volts, right? If I want to control the output voltage, right, I'll go to the equation I had like for buck, because I want to control the output voltage, right? You can see on the power supplies, they have a current mode, right? Have you seen this one in the power supply? You have a voltage mode, you have a current mode. You can put it in the current mode, or so when you put it in current mode, what does it mean? This one is going to act like a current source, right? Look at it here. A steady state. How much current is going there? Zero, right? Basically, the inductor current, if I can regulate the inductor current, basically this system is working like a current source, right? Because current going here is just the ripple current. It's going to be zero, right? The average of this one is zero. If I control average of current here, I'm controlling average of current here. This is like a current source, right? If I want to put it in the current source, what I need? IL over D, right? I want to make sure I have 5 amps, whatever load, let's say I put a variable load here, right? When I'm changing this load, whatever I want to put here, I want to keep pushing 5 amps, right? I have to change my duty cycle, right? So this is a transfer function. See, based on what you are going to control, you should look at your system. Most of the power supply, you have voltage control. You want to control the output voltage, right? So basically, you go with the first transfer function, the top transfer function, right? Because you want to control the output voltage. VC is a VO, right? But for some reason, for example, current mode for the power supply, or solar panel. Sometimes you want to control the current. So you go find this transfer function. Now, if you are going to replace your you're going to replace your boost converter, use this transfer function. When I had those control loop, I see the plan here, right? If you look at the plan, here is going to be I, right? And here is the PWM generator. PWM generator is nothing, just changing the average value to a pulse, right? You will be able to switch your switches. But you have a D coming here, right? Basically, you can get rid of this one. You say, D is coming, I'm going to get IL, right? And this one is going to go to my feedback loop. IL ref controller and bump, right? This way I can control my current, right? This transfer function is this, right? But I have another system. I want to control the output voltage, right? VO, here is going to be VO ref, and the feedback is a VO, right? I should go to this transfer function, right? My plant is this. Just I want to tell you, see, there are different cases. What you want to control is going to be here. It's going to be here. I told you, maybe you need to control the V in, right? So V in should be here. V in should be here, right?
So this is a small signal transfer function?
Yes.
Now when is it not valid?
Oh, very good question. We went through, if you have a very big changes, let's say you have this one, boom, right? These changes, they are not very small anymore. But one of the assumption I had, I said whatever tilde time, another tilde, 0, right? And another thing that I'm doing, see, maybe it's like this, right? The changes will be like this, I assume my IC is equal to, or not IC, IL, is IL plus IL tilde, right? This is the Taylor series, right? If you remember, Taylor series has a DC value, X, X2, X3, X4. Basically, we ignored the rest. We just consider the average plus the X, right? X2 is going to be like tilde times tilde, right? We get rid of those. If the changes are too big, we cannot use this much. And we are assuming if you have a good control system, the changes shouldn't be big, right? They should be around there. So we found a transfer function for the buck, for the boost. We're going to stop here. Tuesday, we are going to go quickly calculate the PWM generator transfer function. And after that, we are going to focus on this one. We are going to focus on this one.